I'm going to be taking you through a tutorial for how to use Graphical Analysis 4.0, which should be on your Chromebooks already, and if not, it's easy to get. So with this, you should be looking at a couple of things. One would be this handout or something similar to that. If you want to print it out, that's fine. If you want me to print it out in class, that's fine also. And then you're going to have a PDF of some data sets that I'm going to ask you to look at as well. So Graphical Analysis is a really nice program. It's free to us, and it does a pretty good job of making graphs that might not be a straight line graph into a straight line graph via some manipulations. So we'll be using this a lot this year. You can also use your graphing calculators. For some of you who are in AP Physics as opposed to regular physics, that might be a preferred way to do things. But Graphical Analysis, again, is something available to all of you. So if you've got your Chromebook, this tells you of how to get it. If it's already on your Chromebook, there's a little circle in the lower left-hand corner. You select that, you type in Graphical Analysis, it should be there. If not, go ahead and get it using that way. So the next thing you're going to want to do once you open it, and I'm going to open it from my laptop, and it looks the same on everything. I think you can even put it on your phone as well. We're going to go to manual entry. So this is a blank data set, or a blank graph. Notice it's untitled up here. You could save it as a title, as a document. So I could say save as sample data set 1 Forrest 2020. And I don't want that in my documents, I want it on the desktop. So think about where you might want to save that. I haven't put anything in there yet, but it's a file. You can have this look like you would want one graph, two graphs, three graphs, a table, graph, table, and meter. I'm not sure what meter is. Yes, nothing. Graph and table is what we had before. If you want two graphs, it could look like that. That might be useful for some things that we're doing. I'm going to have graph and table at this point. Data set 1, you can either rename the data set or add a new data set or delete a data set. So sample set 1 is all I'm going to call it. X-axis, Y-axis, column options. I'm going to name this, and I'm going to use a sample from this down here, sample set 1. Okay. So I'm going to call the x-axis is going to be drop height. We're going to measure that in centimeters. We'll do auto for that. We do not probably need to use scientific notation. I'm going to click on this, column options. Dependent variable would be bounce height, also centimeters, and there we go. So notice that those have put those on those axes right there. I'm going to get rid of this so that's not distracting. This, if you do want to have a sensor set up, we could do that, but we're entering data manually at this point. The other thing is we can give our graph a title, a legend, things like that. Add an annotation, prediction, edit graph options. I'm going to go to edit graph options, and I'm going to give the graph a title, and that's going to be bounce height versus drop height. Normally you would do y-axis versus x-axis as your title. And right now I'm going to let the range be automatic. I may end up changing that earlier. And points is fine. And there's my title. All right, so I'm going to type in the data that I've shown you. It does not have to be in order. It just has to be where the x and y point that you're putting in correlate with each other. So my first data point for the drop height is 100 centimeters. I just hit tab and go over to the bounce height, 87.6. Next one I've got is 80 centimeters and then 70.8. Next one, let's say I misread it and I go down to the 40 centimeter one, and that's 36.0. I say, oh, I've got to go back and put the 60 centimeter drop height in. Doesn't matter what order you put them in the data table, as long as the y and x points, again, coordinate with each other. If you type in something incorrect, you can just take it out. So let's say I've got 56.5 and 37. Well, that doesn't look good, so I'm going to get rid of that. And it shifted all those up. Okay, so that's my data set. At this point, it looks like a straight line for sure, and you're going to want to use something that you've got in your Google Classroom. So I'm going to pull that up. Which is a graphical methods summary. And each class I think that's going to use this should have it. It's going to be somewhere the beginning materials. I'll give you a hard copy in class. So it looks something like this. Now, I do think that they call this in graphical analysis, they call this a quadratic. So that's a little bit of change with the version for this year, as opposed to an exponential or parabolic. I think they do call this a power function, though. Okay, so I'm going to get rid of that real quick. So now when I go down here, if I want to do a curve fit, linear is the one that pops up first, but there's a whole bunch of these different things. Proportional means it might not start from 0. Quadratic, again, is like a parabola concave up. Power is a parabola concave down. Inverse, inverse squared. Some of these ones we won't use too much. Definitely looks like linear. So I'm going to click that, apply, and now if you notice, it's got the range here. It has got a low RMSE, which is a root mean square error. The correlation coefficient is 0.9999. That's pretty good. That's obviously a straight line. The problem is that with graphical analysis, when you apply a curve fit on small data, I've noticed that with something like power quadratic, it will automatically, it's not just a squared function. It basically is saying something like this. If you notice, it's a low RMSE, and I don't like that. It's basically can make all these coefficients such where it looks pretty darn good. We probably won't have that problem very much, but it's something I've just noticed as I've been playing through this or working through this. So one of the things is when you write a mathematical model, you're not going to want to write it in y equals mx plus b formula. Y would be bounce height. M is the slope, which is 0.8733 what units? Centimeters per centimeter. And then the b is going to be very low. And if that's 0.55 and our maximum data is above 80 something on the y-axis, you might decide to put that as 0. So I think I'm going to save that. File saved. And again, there's other things you could do with this. There's different things here in Logger Pro. If I wanted to add another data set, I could do that as well. I could rename this and so forth. So I think that's pretty good. When you do want to do things and it's not a straight line, that'll be a little bit different information. I may make another video about that.